guess that's enough. Let's go back to the studio. So while coding and testing the controller with the robot, I discovered one issue that I've already solved in the past, and that's where you want to control the robot precisely, and yet you want to control the robot fully, so basically from 0% to 100% be able to use all of the power from the motors. But the problem is that the joysticks are just too small for both of them. So you either have to choose whether to limit the speed but have like increased sensitivity, so you can really just control it at low speeds, but then you can't really go up to the highest speeds possible. Alright, so I just wanted to show you this app, but I totally forgot the pin code for the development phone, so I had a little panic attack, but fortunately I remembered. Hey, by the way, that's my face. Hey there. And, alright, so what I just wanted to say is that in the past I solved this issue basically by giving it 3 gears. Normal, fast and slow. Yeah, and in the slow one you have a precise control, but you don't have the maximum speed, and the maximum speed is in the fast one. So that's one way of solving the problem, but right here I chose a different path, maybe better, maybe worse, it will need to be tested. So instead of the linear encoding, I chose exponential. So basically what it does is that firstly you basically increase the speed slowly, and then you increase the speed fastly. Okay, so I'm just going to play around with it. Now try out the controller, how it feels. I think it's, you know, the way we solve the problem with doing the exponential encoding rather than the linear. I think it really helps, because as you can see, I'm not using any gears, I'm using just that, and I can get like pretty cool, pretty nice precision with it, but I can go even the full speed. You just gotta be careful not to damage it. Yeah, it is just a better way of controlling the robot. I mean, the app, if you have it on your phone, it is more practical because you don't have to carry around the controller. But the controller is just, if you compare it like playing some car game with keyboard or with a steering wheel. Yeah, the steering wheel is going to be pretty much always better, and the same goes for the controller. If you're into electronics, robotics, or any kind of DIY project like me, you know how important the high-quality PCBs are for bringing your ideas to life. PCBWay is a manufacturer who makes these PCBs. One thing I love about PCBWay is their commitment to hobbyists, students, and professionals alike. They offer a wide range of services, from standard PCBs like those I use in my controller to advanced options like flexible PCBs. Their platform is user-friendly and the turnaround times are impressive, meaning you can finish your project very quickly. And now they have a massive discount as a part of Christmas and the New Year sales until January 12th. So if you have a PCB you want to order, be sure to hurry up and use this awesome deal. Huge thanks again to PCBWay for supporting this project. Flickering, I mean a lot of flickering right there. I mean, fun to play around with the vibrations. I feel like they're like different tones, so you can probably like make some song from it. And by the way, for all the time that we tested the robot right here or back in the studio, the controller got from 67% to 65%, including with these vibrations. I guess that probably they consumed the most power. I mean, it's so freaking cool. And so what I just wanted to say is that the battery life of this thing is just, I mean, totally incredible. It has those two big Li-ion batteries providing 20 watts of power, and I mean it can, I mean I haven't even calculated the consumption, but I guess if the Wi-Fi of the maybe the Wi-Fi of the chip consumes more power than the vibration motors. That's actually way more probable, I guess. I don't know, but anyway, around maybe 250 milliamps. That's probably what I would guess with everything turned on and even with the OLED display. So, and that's at 250 milliamps at, let's say, 5 volts. And we have around 9. Alright, so 5 volts, so that's per hour, that's, let's call it 1.2 watts. And because all of the inefficiencies in the BMS or the voltage regulator, let's call it 1.5 watts. So in that case, I don't know, maybe around 15, 16, yeah, maybe around 16 to 17 operational hours with the long range. That's, I mean, that's just incredible. Quite cool. You know, I'm really like, not like worried, but I'm really disappointed about the flickering, because I mean I can't see any flickering on the screen, but I don't suppose this display has like anti-flickering option. And even the brightness, I mean, it's not optimal. You can see it, but it's not optimal during like sunlight. Brighter display would be way better, but I didn't want to go for an LCD panel because of the increased consumption because of the backlight. So now for real, let's get back to the studio. Alright, so thanks for watching, guys. Don't forget to subscribe, because in the next video I'll be explaining, probably I will choose the OLED display or the code or the code or the controls behind the vibration motors, or maybe the capacitive buttons or the joysticks or the code itself. I don't know, but it's definitely going to be interesting. So don't forget to subscribe. If you like this video, don't forget to hit the like button. I just want to wish you a happy new year. Thanks for watching, and bye bye. Ooh, nice. Pretty cool video, yeah? I think so. Nice. Yeah, thumbs up.